Namaskar friends, welcome to Electronics Technology YouTube channel. Topic of electronics technology news is laser-driven 3D printing for thermoset structures. With sub-second solidification, 50-micron resolution, and real-time tuning of mechanical and electrical properties, the approach promises faster, programmable manufacturing for flexible electronics, soft robotics, microfluidics, and biomedical devices. Laser-assisted in situ direct write three-dimensional printing enables the fabrication of freestanding thermoset structures. A research team at Xiamen University, XMU, has unveiled a major advance in 3D printing of thermoset materials, a leap that could reshape manufacturing of flexible electronics, soft robotics, biomedical scaffolds and more. The newly developed method, described in a paper titled Laser-Assisted Direct Three-Dimensional Printing of Freestanding Thermoset Devices, integrates in situ laser-induced solidification with direct ink writing. Laser-assisted in situ direct write three-dimensional printing enables rapid fabrication with real-time property control. This enables creation of intricate, freestanding thermoset structures without any supporting material, a major improvement over existing methods that often require support and then removal. During printing, a tightly focused laser rapidly cures the polymer jet via a strong photothermal effect, triggering cross-linking in under 0.25 seconds. The process achieves a structural resolution as fine as 50 micrometers, and notably allows real-time tuning of material properties. Mechanical modulus can be altered by up to 10-fold, while electrical properties can be modulated by up to 20-fold. Laser-assisted in situ printing technology enables the fabrication of three-dimensional flexible sensor devices. This combination of speed, precision, and tunability marks a significant departure from conventional direct write 3D printing approaches, thermal, acoustic, or UV-assisted, which often suffer from low curing efficiency, limited material compatibility, restricted performance tuning, and dependence on supporting structures. The implications are broad. Researchers say this fast, stable, programmable manufacturing strategy could accelerate the development of complex, multifunctional thermoset devices suited for flexible electronics, microfluidic systems, soft robotics, organ-on-chip platforms, and biomedical scaffolds wherever intricate point 3D architectures and bespoke material properties are required. In effect, XMU's innovation could lower a key barrier in additive manufacturing of thermoset-based devices, by eliminating the need for support materials and enabling on-the-fly control over structural and functional properties. The new method offers a more efficient, scalable, and versatile route for fabricating advanced components in emerging tech domains. Do you like this video? Please subscribe, share, like and press bell icon for getting notifications of Electronics Technology YouTube channel, and for searching my YouTube channel please write @electronics technology 50.